Hello everyone. So last time in previous video, the video is not audible, so I'm repeating this video to prove the statement of Euler's theorem. So now the statement is given here that x del u by del x plus y del u by del y is equal to nu. That is, we have seen in previous part of different types of a problem that we are going to that we have solved. So now in this part we are proving the statement of Euler's theorem. First of all, I will take a function u is equal to x and y. I will take only two variables to prove the Euler's theorem. So let me give the given that u is equal to f of x comma y is a homogeneous function. By default, I believe that the given function is homogeneous function of degree n. So another statement of homogeneous function is also proved that u is equal to x raised to n phi of y by x. This is also the statement of homogeneous functions. Either you can choose u is equal to y raised to n phi of x by y. So let me take only these equations and I will put the name is equation number 1. So now partially I will differentiate this equation 1 with respect to x and another with respect to y, and I will find del u by del y and del u by del u by del x and del u by del y. So first of all, let me take partial derivative with respect to x. So remaining other variables, that is y, is constant. So find out del u by del x. So you have just is equal to del u by del x is equal to, now focus on this equation. So x raised to n, I will consider this is u and this is v. So by uv method, partially derivative. So x raised to n, that is as it is. Now take derivative with respect to x, this function. So phi prime y by x into, that is chain rule, minus y by x square. Clear? Plus now this function will be as it is in the next term. So phi of y by x. Now I will partially derivative, partially differentiate this function x raised to n, that is n x raised to minus 1. So the simplification of this function is x raised to 2, that is in denominator. So I will put x raised to n minus 2 phi prime y upon x minus 5 plus n x raised to n minus 1 phi of y by x. Clear? So that is your del u by del x. Now I will differentiate equation number 1 with respect to y. So therefore del u by del y is equal to, x is your constant when you take partial derivative with respect to y. So remaining other variable, that is x, is your constant. So x raised to n, that is as it is. Now I will partially differentiate these functions only. So I have del phi by del phi del phi prime y by x into now y by x chain rule, that is 1 upon y. So again I will simplify this statement. I have del u by del y is equal to x raised to n minus 1 phi prime y by x. So I will put the name here, that is equation number 3. Simply now the statement of Euler's theorem is x del u by del x plus y del u by del y is equal to, that is, put the values of del u by del x and del u by del y from the equation number 2 and 3. Then I have x, then the x into value of this statement, that is from equation 2, and plus y, that is your y, and statement from equation 3. And I will simplify this function. Then I have n into bracket x raised to n phi of y by x. After simplifying this statement, that is in bracket, I have n into bracket x raised to n phi of y by x, and therefore I can say that this is equal to u. So therefore x del u by del x plus y del u by del y is equal to n into u. So n is your degree for given particular homogeneous function. So hence we have proved the homogeneous function. Now by taking a problem, we are going deeply to understand how we can prove the Euler's theorem. So simply I just take a problem statement that is here. if u is equal to 1 upon x square plus 1 upon xy plus log x minus log y upon x square plus y square, then we have to prove that x del u by del x plus y del u by del y is equal to minus 2u. So simply from this statement we can say that the degree of homogeneous function is minus 2. So just we have to prove this statement. So first of all I will write solution of this, that is first of all write the statement or given function, that is u is equal to 1 upon x square plus 1 upon xy plus log x minus log y is equal to, sorry, log x minus log y upon x square plus y square. Again simplify this statement, u is equal to 1 upon x square plus 1 upon xy plus log x upon y x square plus y square. That is your function u. Now you have to prove that either this function homogeneous or not. So you have to take f of lambda x lambda y, you have to replace x and y by lambda x and lambda y. So thus you have 1 upon lambda square x square plus 1 upon lambda square xy plus, now I will put lambda x log lambda x lambda y upon lambda square x square plus y square. Now lambda is cancelled, so now you have lambda raised to minus 2, lambda raised to minus 2 and lambda raised to minus 2. So now common out lambda raised to minus 2, then you have f of lambda x lambda y is equal to lambda raised to minus 2 1 upon x square 1 upon xy log x upon y upon x square plus y square. So this statement is equal to lambda raised to minus 2 f of x comma y. So now we can say that the given function f of x comma y is homogeneous function of degree minus 2. So we can write the given function f of x comma y is homogeneous function of degree n is equal to minus 2. Then by the Euler's theorem statement, by the Euler's theorem, we have x del u by del x plus y del u by del y is equal to n into u. Now put the value of n, that is minus 2 into u. Hence we have proved. Similarly, I will take another example based on that. So another example I will take, if u is equal to f of x upon y comma y upon z comma z upon x, then we have to find the value of x del u upon del x plus y del u upon del y plus z del u upon del z. You have to find the value of this statement by Euler's theorem. So first of all I will write down the solution. The solution is like, first of all write down the statement that given f x upon y, y upon z, z upon x. Now we have to prove either this function is homogeneous or not. So I will take f of, now just put f of x comma y comma z, that is variable of 3 independent variable x y z. So f of lambda x lambda y lambda z is equal to, put the values of x y and z by lambda x lambda y and lambda z. So you have f of lambda x lambda y, sorry, lambda y lambda z and lambda z lambda x. So lambda cancel in 3 sides. So now you have lambda raised to 0 f of x upon y, y upon z, z upon x. So we can say that the given function u is homogeneous function of degree 0, so therefore we have n is equal to 0. So the statement of Euler's theorem, we have statement of Euler's theorem, we have x del u of del x, y del u of del y, z del u of del z is equal to n into u. So put the value of n, that is 0. So now I have 0 into u, that is 0. Hence the values of this statement is 0. Clear?